Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter thermal properties of matter. Okay, so let's go through the question. The question is two rods, one made up of copper and other made of steel of the same length and the same cross-sectional area. Remember it, are joined together. The thermal conductivity of copper and steel are, this is for copper and this is for steel, joule second inverse, Kelvin inverse, meter inverse respectively. Okay, the free ends of copper and steel are held at 100 degrees Celsius and 0 degrees Celsius respectively. Okay, what they are asking, the temperature at the junction is nearly how much value. Okay, so here I have taken here the two rods. Now, so first one, what is given here? First rod is the copper, so let's take here Cu, and the rod is what here? Kindly see, the other rod is here steel. Okay, so steel I am writing here, steel. Now, so here what will happen that here one of the end at 100 degrees Celsius. Let's take, I am writing here T1 100 degrees Celsius. Okay, and this end let's take a T2 0 degrees Celsius, and the temperature of the junction how much here? T. Okay, after that if we talk about here the dimensions, anyhow the both of them are having the same dimension. Let's take here the here dimension is what here L, this rod is also having length L. Now, and area of cross section like this, if in case this is the cylindrical rod, so area of cross section for both the rods how much here? It is given A. So what we have to calculate? We have to calculate the temperature of the junction. Okay, so here when we are solving, remember the basic formula. Basic formula we are going to use heat current. What I am using? The term H, heat current. Heat current means the rate of flow of energy dq by dt is called what? Heat current. No? So rate of flow of energy is called heat current. Remember the formula? Ka, this used to be the T1 minus T2 by L. Okay, T1 is the temperature of one junction, and T2 or T1 is the temperature of one side, and T2 is the temperature of another side here. Now, like this, if I write here, now this rod is there. Okay, and here this is T1 and this is T2. What is K? K is called the thermal conductivity of the rod. Depends upon the nature and the temperature of the rod and all that. Okay, okay, K is the constant. No? K is constant thermal conductivity, depends upon the nature of material of the rod and all. A is the area of cross section, L is the length, T1 temperature of one junction, means T1 is the temperature of one end and T2 is the temperature of another end. Okay, this is the basic. Now after that you have to remember that one thing, when these rods will be joined, okay, when these rods will be joined, we are considering that by default always these rods are in steady state. Okay, and whatever heat will enter from one end of the rod, same heat we will get out of the rods also. Okay, and there should not be any what to tell radiation of the heat, so that by default we are always considering these rods are wrapped by one insulated paper. Okay, so what we can write here, let's take, if here heat current is H1 in this rod and here heat current is H2. So what we can tell here, by default always because both the rods connected in series also, we can tell from one point. So we can tell heat current of one rod will be equal to heat current of a second rod, because they are connected in a series. Is it? They are connected in a series. Like two resistors are connected in series, electric current is same. So here when the rods are connected in series, what will be same? Heat current will be same. H1 equal to H2. Okay. After that we'll use the just formula here. Now, so H1, what is the H1? Copper. This is what? Copper. Or I will use just term Hc. Second one, what is there? Steel. So I will use the term here Hs. So Hc is equal to Hs. Okay. Now Hc how much here? See, Kc into area of cross section, temperature, difference between the ends, this is T1, this is T. So T1 minus T by L is equal to, for the steel, Ks, A, temperature difference. Heat always flows from high temperature to the low temperature. That's why we have taken like this. What is the H2? It is given here T minus 0 by L. Is it? Can you see here? After that, what are the things will cancel out? See, this L and L is cancelled. this A and this A is cancelled. Okay, can you see very well? Is it? So after that, when we'll write here, see, I'm writing here Kc T1 minus T is equal to K still T minus T2. Okay. After that, we'll put here the values. Now, copper, what is given here? For the copper, 385, and for the steel, 50 thermal conductivity, and the temperature T1 is the 100 and T2 is 0. All this we are going to write here. Okay. So see here, this is given here 385. Here how much here? 100 minus T is equal to Ks. How much here? Again I will check. I think so 50. Is it? So see here 50 is there. Okay. So this is the 50 and T minus what is given here? 0. Okay. Now we are just left with the calculations. So we can write here, see, 38500 minus 385T is equal to 50T. Is it? After that I can write here, see, 385T plus 50T is equal to 38500. Is it? So now if I write here the 385 plus 50T means I can write here 435T, correct, is equal to 38500. Is it? So hence if I write here the temperature of the junction, 38500 by 435. Okay. So when you will solve here, you can see here the 38 something, this side 4, is it? And you know 4 8 is 32, is it? So something 8 will be involved here, no? First digit. So you can see very well here, the first digit is what? 8 here. So 88.5 degrees Celsius, it will come approximately. And here in this kind of question, no need to convert this degree Celsius into Kelvin. Is it? Can you see very well? Is it? So if we talk about here, the which option is correct here? The correct option is here, option A is the answer. Is it? So students, I hope so this question of thermal properties of matter from the topic modes of heat transfer, and here which mode of heat transfer is there? The conduction is very clear to you. Keep studying, keep growing.